All right, so here's a bunch of examples that we can practice, okay? And what I'm going to do, I'm going to walk us through these calculations. I'm going to play a little bit of music in the background while I'm doing it. You are welcome to just even pause the video and try these calculations out for yourself, or you can kind of watch me work through these while we're listening to some chill music here. Yeah, and then we can talk about the result after that. Okay, let's get it going.
The revolution will be televised. And the pollution from the ocean, now with devotion, push peace and keep it in motion.
You know, I wanted to say I got a little too funky with this. Getting all excited about listening to my music, I forgot to kind of describe my process. So I'm going to draw a picture over here when we do unit analysis. And that picture is, I'm going to start here. I'm going to draw a circle. This circle represents the number in the question. Okay? That's what we start with. We start with the first number we're given. And in this problem, how many kilograms are in 1 teragram? Well, we were only given one number to begin with, so that's where we're going to start, with 1 TG. We're going to start with whatever number we have. And then the process is going to be a series of multiplications and divisions. And the pattern that I like to do is to start at the top and go to the bottom. And then go up, and then go to the bottom. And then go up, and then go to the bottom, and then go up until I'm done. And how do I know when I'm done? Well, I know when I'm done because I end up with the unit that I want, okay? So for example, let's walk through this one, and then maybe I'll also walk you through B, and then we'll go back to the gorillas for part C and part D, okay? So I'm going to start with that 1 teragram like they gave me. And now my goal is to go down. Well, what am I going to put down there? I want to put the exact same unit, 1 teragram, okay? And I'm going to do that because now when I divide this teragram by this teragram, that's going to cancel that unit out, okay? And so what am I going to put up here? Well, the best thing you can put up here is the gram. And now we're going to write that definition that I got from right here. So I can see 1 teragram is 1 times 10 to the 12th grams. I know it's not on the list of things I have to memorize, but we can still, in this case, use this sheet to help us calculate it, okay? So now I need the number of teragrams that are in 1 gram or vice versa, okay? And so I'm going to say in 1 teragram, there's 1 times 10 to the 12 grams, okay? So now I've gone down and then up, and then now I got to do it again. And so now when I go down to this way, okay, I'm going to write grams because I want that to always be the same so that my gram and my gram unit can cancel. And because I'm trying to get to kilograms now, and I look back here on this sheet, I can see, oh yeah, I know that a kilogram is 1,000 grams, okay? So now I can say there's 1,000 grams in 1 kilogram. And then now when I look through this, okay, the teragram and the teragram, when I divide that by that, it cancels. And when the gram and the gram, when I divide that out, it cancels. And then now I'm left with kilogram. So now I know that I can stop. And then I've done the math on the units already, right? I've divided out the units like I need to. Now I have to do math on the numbers. And so this goes 1 times 10 to the 12 divided by 1 times 1 divided by 1,000. You'll recognize all of those ones, right? Don't matter. I mean, they do matter for the units, right? But for the math, we know 1 divided by 1 is just 1, right? So it's really just 1 times 10 to the 12th divided by 1,000. Okay, I'm going to try to show you a cool little trick on your calculator, because I know a lot of you are going to want to enter in 1 times 10, 12. Okay, so I think I can do this. Yeah, here we go. I'm going to say 1. I'm going to use this double E button. E 12. So that gives me the equivalent of 1 times 10 to the 12. And now I'm going to say divided by, oh, this is hard to do, 1,000. And if I count all those zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros. And look, if I move my decimal place, 1, 2, 3, 4, 5, 6, 7, 8. I can't count and do this, but you have to trust me that it's 1 times 10 to the 9. Okay? So that gives me 1 times 10 to the 9. And then the unit that's left is the kilogram. Okay? So let me put a different color on this. Okay, so remember, I started with the number that I was given. Then I went down to that unit, and to go across and up, I need to use that conversion sheet. Okay, and then from the gram, I went back down and kept the gram, and then I used the conversion sheet to go back up there, and I was left at the same number. Okay, so let's try. I'll walk you through this one, this part B, and then I'll work through C and D on my own. Okay, how many nanometers are in 6.5 times 10 to the 2 terameters? Okay, so how do we start this thing? Well, we start with the number we were given. In this case, 6.50 times 10 to the 2, and that's a terameter, TN. Okay, so automatically, without question, I know I'm going to go terameter, and I'm going to put a terameter down here, and then I'm going to put a meter up here. And I could even finish this off like to the end game, right? I can then know that the next thing I'm going to have to put down there, I'm going to follow this. I'm going to say meter. And then it's asking me for nanometers, so I can go meters to nanometers. Okay, so from the first one, right, we remember a terameter is big, so that means 1 terameter is 1 times 10 to the 12 meters. But what about this nanometer? So a nanometer is really small. There it is. It's 1 times 10 to the minus 9 meters. So there's a couple different ways that I could write that, okay? I could say in 1 meter, there's 1 times 10 to the negative 9 nanometers. Or I could have said there's 1 times 10 to the positive 9. Oh, wait, hold on. I messed that up. Make this a positive. Yes. Let's erase that and try that again. Okay? In 1 meter, so I'll back up for a second. Because a nanometer is small and a meter is big, that means there has to be a lot of these and only one of these. Right? Yes. Okay. Yes. Sorry, I just cheated. Okay. It's the first day. I'll forgive you for your mistakes if you forgive me for my mistakes. So, yes. So we know that a terameter is much bigger than a meter, and same, a meter is much, yes, a meter is much bigger than a nanometer. So these all check out. All right. And so now I can say terameter cancels with terameter, and meter cancels with meter, and I'm left with nanometer, which is what I'm trying to get to. Okay, equals. And so now my math is going to be 6.5 times 10 to the 2 times 1 times 10 to the 12 times 1 times 10 to the 9. And that's going to give me a big number. That's going to give me 6.50 times 10 to the 23 nanometers. And that makes good sense because a nanometer is really, really small and a terameter is really, really big. So it makes sense that we would have a really large amount of nanometers to fit in a terameter. Okay, so I'm going to play the music and work on these next two on my own. So you're welcome to pause the video and try it for yourself, or you can work alongside with me.
Kids gather around, yeah, I need your focus. I know it seems like the world is so hopeless. It's like Wonderland. Fascinate me, picture and animate me, cause I'm rolling, keep holding, click clacking, crack whacking, folk packing, roll stacking, acting a fool when I teach. Welcome to the world of the plastic beach. Yeah. Welcome to the world of the plastic beach. Mirror, mirror on the wall, boss dog, give it to us, give it all, turn it up, speed it up, slow it down, underground way under us, undercut, shipped up, shipped out, swimming with the shorts with the views up, turn the wheels up, real tough, drinking lemonade in the shade, getting green with a gang of pills up. Yeah, this my path, everybody rockin' while I'm rockin' in the bubble bath. And I'm just like that. Hoes on ready up to get you more cash. Yeah, so quick, so fast. All the kids say they love me when I'm on the welcome to the world of the plastic beach. Yeah. Welcome to the world of the plastic beach. Welcome to the world of the plastic beach. Yeah. Welcome to the world of the plastic beach.
Okay, we got to another interesting one here with volume and these cubic decimeters, okay? So whenever we have a volume, we first want to use the distance version, okay? So I'm going to put just a decimeter, even though what I know I really need is a cubic decimeter. So I'm going to put decimeter down there. And I know that then what I do across that line is to go to the base unit, okay? And let's deal with this first before we move on, because I got to make this a cubic decimeter. Well, I know that there's 10 decimeters in 1 meter, okay? But now look what I can do. I'm going to put a parenthesis around this whole thing and cube it. Cube it. And so now when I cube this, that means I'm going to have in 1 cubic meter, there's 10 to the 3 cubic decimeters. So remember, if I cube the unit, I have to cube the number, okay? So you could apply that 3 and recognize that that's got to be 10 to the power 3, 1 to the power 3, m to the power 3, dm to the power 3. And that'll give us that'll cancel the cubic decimeters. But now you have to note that we have a cubic meter on top there, right? So that's going to be a cubic meter down below. And let's see here. If you recall from our conversions, here we go. 1 cubic meter equals 1,000 liters, okay? So let's keep going with that. So 1 cubic meter was 1,000 liters. So now my cubic meter and my cubic meter is canceled, and I'm left with liters, and I can calculate all the way through. And when I do that, I get 8.0 liters. Haha, so maybe you remember this sneaky little thing here, 1 cubic decimeter equals 1 liter. Okay, so that's all we did. We just proved that, right? We got 8.0 cubic decimeters is 8.0 liters. Okay, when I do 8.0 times 1,000 divided by 10 to the power 3, because 10 to the power 3 is 1,000. Okay, so moving along.